Hey students, so we are on the circle vocab. I'm getting ready to pull up a PowerPoint, but I want you to know that you need to be in the very back of your vocab folder, page 30. You're going to copy everything in here. You do need highlighters, and you're even going to draw some things on the back, and I don't care where you put that on which back page, but just try to draw a circle and do your best with it. Okay, so I'm going to jump right into the PowerPoint. All right, circle vocab. All right, definition of a circle is the set of all points equidistant from a set point called the center. So in the center of the circle, let me see if I can get a little laser pointer going on here. All right, in the center of the circle, I want you to pretend like if there was a peg in the ground and a dog on a chain. That dog could go to each of these places, but he could never go past it. If that dog continued to do that for years and years and years and years, there would be a path right here where the dog could go to, but it could never go past it. So the set of all of these points continue to be built together and they make a circle. The set of all points that are equidistant. By the way, the distance is the radius. Okay, that's how long the chain is for the dog. So if you think of it that way, that's not hard to understand at all. Now, the way we name a circle is we name it with a capital letter. So usually you see the letter C at the center. There could be O at the center. Lots of letters they use. It doesn't really matter. But you would name it Circle O. I'm going to do my best to draw this for you. So just bear with me. I'm drawing with a mouse, people. Okay, so if I was going to name this circle, let's put a dot there. And if I put a C for the circle, I would name it. Now, it's not going to draw very well, but I would do a circle with a dot in it. And then I would put wow, that is just amazing. That is not what I tried to draw. Okay. Anyways, you would put a little, not going to do it. I will show you later. You will see it on the worksheet. It is a little, wonder if I can erase all of this. Oh, I can. Beautiful. We're going to move on. Okay. Next slide. All right, you guys know what a radius is because this is not the first time you should have seen it. So a radius is a segment. You will name it. If this was an A and a B, you would name it segment AB, just like we've always done. A segment that has one end point on the center and the other end point on the circle. Center on the circle. That's a radius. If I go too fast, just pause the video and get it filled in. Okay? Diameter. So a diameter is a segment that contains the center and has both endpoints on the circle. It is a segment. So if this was an A and this was a B, we would call it segment AB, just like we've always been able to name. And it is the segment from one side of the circle to the other going through the diameter. All right, congruent circles. Congruent circles, now remember, all circles are similar, but in order to be congruent, they would have to have the same measurement for the radius. So the radii would have to be congruent. So if this was 4 centimeters and this was 4 centimeters, then you would have congruent circles. We don't do a lot with that. Okay, next we have a chord. A chord is our last segment. A chord is a segment that has endpoints, P and Q, you can see them in the picture, endpoints on the circle, but it's not the diameter. So true or false, is the diameter a chord? True, yes, it is a chord, but we do not call it a chord. The diameter has a special name called the diameter. We don't call it a chord. Okay, now, the easy way for you to remember a chord is if this was a round cake and I wanted a piece of the cake, I would take my knife and I would just chop that piece off. So a chord chops, and if you chopped it, the piece of cake that would be left from P to Q, that's a chord. All right, next. Okay, secant is our first line. Notice it has arrows on it, so draw the arrows on it. A secant is a line that intersects a circle at 2 points. Okay, so this is where you guys are going to have to really pay attention. A secant contains a chord. If there were letters on your picture, you can put an A and a B. Okay. If I wanted to know what the secant was, you would have line AB, okay, with the line symbol above it. If I wanted to know what the chord was, you would say chord AB. And we'll talk about this a little later in the notes. Okay, secant AB and chord AB. All right, so secant has the arrows on it. A secant slices through the circle. That's why it has arrows on it. It's able to pierce and continue on forever. It slices through. A chord chops straight down, but a secant slices right through. All right, next. Tangent. So a tangent is a line that intersects a circle at one point. So where the red dot is, that is where that circle and the line are touching. So a tangent touches. Chord chops, secant slices, tangent touches. And it touches at exactly one point. That point is called the point of tangency. Okay, so the next picture, put a big red dot or something here, a dot, to show that is the point where that line is touching that circle. It's the point. All right, on the back of page 30 or somewhere, I don't care, draw me with your best drawing ability a circle. Okay, draw me a circle, and then I want you to put all of these in here. Make sure these two have arrows. The others are segments, because it's really important if you're going to study that you look back at this picture and that you know a chord, a radius, and a diameter are segments, and then a secant and tangent are lines. Okay, so go ahead and draw that, and then we'll move on. You can pause the video if you need to. Oh, and please use a straight edge. All right, I'm moving on. Pause the video if you're not done. Okay, tangent circles, circles that touch at one point. Where the red dot is, that's where they're touching. So the orange and red are touching. The red and the green are touching. Even the orange and the green are touching. So the orange and the red are called externally tangent because they're touching and they're outside of each other. The orange and the green are called internally tangent. And the red and the green, if the orange wasn't there, the red and the green are externally tangent. The green and the orange are internally tangent. Okay. Next. All right, now we have something called common tangent lines. So look at the difference. It's a line that is touching two circles. There's only two ways you can do it. Either this way. Well, actually, there is another way, but this would be common internal because it's going in between the two circles. And then this is a common external because it's on the outside of the circles. The other way that you could have this is if I had the circle in here, the line would be going down like this. Use your imagination. And that would be common external. Okay, because it's touching both of them externally. It's not going between the two circles. Okay, between is internal, outside of it is external. That's pretty common sense. You could figure that out. All right, moving on. So also on the back of page 30 or anywhere, I want you to draw this picture. We're going to go over how to name those. So pause the video and draw this picture just the best you can. Actually, you know what? You don't even need to draw it. We're just going to write these down. Okay, so the center of the circle would be C and then G. Either one of those would work. And you just put C or you just put G. The center, put center, C or G. Okay, a chord, if you look, I don't have any chords that are by themselves, but A, B is a chord if you have it as a segment from A to B. That's the chord. Okay. Diameter, BH, segment BH is the only diameter in the picture. Radius, there's a bunch of them. Okay, so radius is a segment, just pick one of them. BC, DC, HC. Remember, you can say CH or HC, it doesn't matter. But then also down here, EG is a radius and GF is a radius. Point of tangency, there's several in the picture. D, if I look where the dot is, that's a point of tangency. H, E, and F, all of those are points of tangency. What do you notice about a radius and a tangent? Look at all of these that are showing up. I didn't even tell you that, but it's showing up in the picture. It's a theorem for geometry that a radius and a tangent are going to be perpendicular, and then we can do Pythagorean theorem. All sorts of neat things are going to pop up. Okay, a common external tangent would be line HF. That is a common external tangent. A common internal tangent, line DE. And then a secant would be line AB. Okay. So you got to know your circle parts. So all the circle parts other than we have not introduced the arcs yet, okay, or the angles. Those are all the segments in the circle. All right, moving on. Concentric circles are circles that share a common center, like a bullseye. So all of those circles have the same center, which is right here. So the little black circle has that center, then the white circle has the center, then the black circle has the center, white circle, black circle. They all have the same center. All right, now let's talk about angles. So you do need to make sure you draw these pictures, be neat with it, okay? So a central angle is an angle that has the vertex at the center of the circle. How hard is that definition? Okay, it's an angle with the vertex at the center. So angle, you would write angle with the angle symbol. Angle AOB is a central angle. You could also say angle O if there's nothing else around it. Angle AOB. Okay, then we have what's called an inscribed angle. So an inscribed angle has the vertex on the circle and the sides are chords. Notice these are chords. The side could also be a diameter because a diameter is a chord. Okay, but an inscribed angle has the vertex on the circle. We're going to be doing a lot with inscribed angles. Okay, draw on the back of page 31, and I'm going to talk a little bit about this picture. It looks like something's written here, but you can ignore it. Okay, so draw this on the back of page 31, and then we'll talk about it. Okay, so my central angle is in green, and they told us that it was 60 degrees. My inscribed angle is in red, and they told us that this was 30 degrees. Can you make an assumption about an inscribed angle compared to a central angle compared to an inscribed angle if they have the same intercepted arc or they have the same end points on the circle? So what happens is we're going to learn about these arc measures, and we're going to learn that the arc measure, remember, this is 360 degrees, and then also this is 360 degrees. So this degree measure matches this arc. So this arc is 60. The central angle is equal to the arc. And then this angle is 30. The central or the inscribed angle is half of the arc. And we're going to do a lot of problems with that because that's a really neat property of geometry. Okay, moving on. All right, use your highlighter definitely. And just, you can draw that circle and then highlight just parts of it, different colors. Those little highlighted parts are called arcs. Arc is the part of the curve of a circle. Okay, we have 3 types of arcs. We have little arcs, big arcs, and we have halfway arcs. Okay, they all have names. Arc is the part of the curve of a circle. All right, so we have a minor arc. A minor arc is less than 180. Okay, so in red, this is a picture of a minor arc. So it's an arc of a circle that is formed by a central angle. So I've got my central angle B, and I've got the arc that's being formed. It is a small arc, less than 180 degrees, and we now have a new notation. Okay, new notation right here. All right, so this is how you would write an arc, is you have this curve, so it's like we were drawing a line or a segment or a ray. Now we have the curved arc. So to name a minor arc, you use 2 letters for a minor arc, and you put the arc symbol above it. Okay, it doesn't matter, just like before, if you say arc AC or arc CA. It's the same thing. Okay. All right, next slide. Major arc. Now in the picture, I need you to use your highlighter. The major arc is in orange. Okay. So definition of a major arc is an arc of a circle that is formed by the exterior of a central angle. And that is the orange in this picture. It is a large arc, bigger than 180 degrees. Okay, remember, a circle is 360 degrees. So the way we would get a major arc, we're going to learn that in just a minute, is you take this little piece here, subtract it from 360, and it leaves you the major arc. And then when we're exactly halfway, so I'm on the diameter, has to be going through the center. A semicircle is actually, people are like, what's a semicircle? Yes, the purple, all of it is what we typically see as a semicircle, but a semicircle is also half of a circle based on just the arc. So what I'm showing you here, this is the semicircle arc, and we call it just a semicircle. So a lot of people say, well, the whole thing is a semicircle. It's half of a circle. Yes, but also the arc is considered a semicircle. You do not have to write this down, but let's go over it. Oh, I didn't go back. Like that. Okay, the way we name a major arc is you are going to use, if you want to write this down by the major arc, 3 letters to name it. So in this picture, I don't have enough to name it. So if you want to, let's put like about right here where I am, let's put a letter B. And if you were going to name this major arc, you would name it arc A, B, C, or CBA. Pretend there's a B where my red dot is. So you would use 3 letters to show that it's a major arc. I can't say arc AC because I don't know if I'm talking about the orange arc AC or the green arc AC. So I have to have a 3rd letter to show that it's the major arc. And it doesn't matter forward, clockwise, counterclockwise. It doesn't matter which way you go when you're naming those. Just make sure you go bigger than 180 degrees when you're naming that arc. Okay, and then the way we name a semicircle, it doesn't matter if you use 2 letters because you will have a letter here and you will have a letter here. You can name it with 2 letters or 3 letters. It doesn't matter. Semicircle, I could say if this was A and B, I could say semicircle AB, or if I had an F right here, semicircle A or arc AFB. And it names the same thing because you're tracing the outline of that half circle. Okay, now, so let's review what I just showed you. So a major arc is a measure more than 180. An example in my picture is arc. Here's how you write it. Arc MNO. So watch my marker. M. Now I can't go this way because that hits the O first. I have to go this way. MNO. So I'm highlighting right here. This is a major arc, bigger than 180, and I use 3 letters to name it. Okay, minor arc like MO or NOON. Okay, and you're look at how you label it. And then a semicircle is equal to 180. You can use 2 letters or 3 letters. It doesn't matter if I say M-O-N or if I just say M-N. I'm still naming a semicircle. All right, so the measure of a minor arc, I need you to make sure you draw this in your picture, that if the angle at the center is 50, then the arc is 50. It is the same measure as the central angle that formed the arc. Measure of a minor arc, arc AB, is the same as the central angle. So look at how I wrote that down here. The measure of angle APB is 50, then the measure of the arc is 50. 50 degrees, 50 degrees. Measure of a major arc. We're going to take 360 and you subtract the angle here. And so 360 minus 50 would give us 310 degrees for the major arc. Look how they wrote it. Arc ADB. ADB would be 310 degrees. That should make sense to you. You guys know 360. Okay, so here's a good picture. Draw this on the back of 32. Just draw it very quickly. So the red is showing a minor arc, less than 180 degrees. The green is showing a major arc, greater than 180 degrees. So my minor arc would be arc AB. My major arc would be arc ACB. There's no semicircle in this picture because there's no half of a circle. Okay. All right, and then just some other things that show up. We have congruent arcs. So if you have the same measure in here, then the arcs are congruent. So if this is 50 degrees and 50 degrees, then the arcs would have to be 50 degrees as well. Arcs with the same measure. Well, you don't do much with that. Okay, inscribe and circumscribe. Inscribe means to draw a circle inside a polygon. We used to do this in geometry with compasses and learn how to do it, but we just don't have time anymore. So when you're drawing a circle inside the polygon, the circle has to touch the shape that you're drawing it in. Okay, so notice a triangle, it's touching at 3 places. The square, it's touching at 4 places, and so on. Okay, and then if I draw a circle outside, circumscribe, you're going around the circumference. Notice the square, all the vertices are touching, the rectangle, all touching, the trapezoid, all touching. So every vertex has to be touching the circle for the circle to be circumscribed. Inscribed, the circle is inside. Circumscribed, the circle is on the outside. Okay, and then last we have what's called an intercepted arc. The intercepted arc, you're going to hear me say that. The intercepted arc is how you determine the central angle or the inscribed angle. So if this intercepted arc was 80 degrees, this angle right here would be 40 degrees. Okay, so this angle is half of that arc. We will learn that later on. All right, you should be able now to complete the top of worksheet 59 and start the extra practice page 1 and 2. The extra practice page 1 and 2 is very, very easy to do. It's all vocab. So you should probably go ahead and jump in and start doing worksheet 59. The top part is all vocab and how you would name it. And then the extra practice is using the vocab and applying it to a picture. Okay, so that is the end of this video notes. And like I said, we're going to jump right into the rest of it, which is area and circumference. And that's going to be another video. Thank you, students.